Hello there, everybody. Welcome aboard. Here's your warm-up. Watch how. Find the surface area and the volume of this rectangular prism. See what you guys can do with that. You're going to want to pause the video because we're about ready to get this show on the road. So pause the video, do that, and away we go. Thank you. I got it. Not. I think if I fix it before I announce it, I'm good. Let's see. I think you might be right. Maybe we'll split the difference, huh? Let's see here. Are they good? They're good. We'll see. I think I might need their Chromebook today. I always forget this part. All right. Okay. Can I get you back up here in 5, 4, 3, 2, 1? Let's see here, guys. Let's see. I gotta get this all shuffled up, put together. We'll pop some accents in there in just a minute. Let's see here. Can I get a little help from David? David, how did you find the surface area of this rectangular prism? Oh, good. Well, not good that you got confused. It's good you got some help. Sure, sure. The thing is, with a rectangular prism, it's kind of hard to talk about the bases because really every face is a base. Because the idea behind a prism is that the base is the figure that is connected by rectangles. But in a rectangular prism, everything is a figure connected by rectangles. So any of them can be the base. You mean the top and the bottom in this picture? Very good. Which is a total of 50. Let's see here. There are 4. Yep, there's 4 of those because there's 9 here, 9 here, 9 here, and then 9 in the back. So it would be 9 times 5 times 4, which is 45 is 180? 180 inches squared. Add them up, and you should get 230 inches squared. How many of us got 230 inches squared for the surface area of that? Perfect. Let's talk about the volume. Let's see if I can get a little bit of help. This one's going to come from George. How do you find the volume of that thing? Yep, 9 times 5 times 5, which is 45 times 5. What was it, 225? 225 inches cubed. How many of us got 225 inches cubed for that? Perfect. So we're going to return to this guy in just a minute. In the meantime, guys, it is the 137th day of school. You know that 137 is one of 8 known stern primes. A stern prime works like this. A stern prime is a prime number such that if you take some other prime number plus 2 times any number squared, if you can get it, that's not a stern prime. Okay? So that is 137 cannot be written as a prime number plus 2 times some other number or some number squared. 3 is another stern prime. That feels a little silly. I think 5 might be, but can someone tell me why 7's not a stern prime? George?
4 plus...
So, you're on the right track. Wait, is it? Maybe it is. Hold on. Is it... No, you know what? 5 isn't a stern prime. Here's why. It's 3 plus 2... No, maybe it is. How about this? If we put in 3 and 2 there, 2 squared is 4, 2 times 4 is 8, 8 plus 3 is 11, so 11's not a stern prime, because I can write it in that way. I think it might be 3, 5, 7, and then, like, these other weirdos. Happy International Waffle Day!
Yes.
Yay! Waffles are the best. They're so good.
They're like pancakes?
Absolutely. There you go. It's the pancakes that have been hitting the gym. I like that. All right, let's see here, guys. What is our first essential question? And I would love to get that from Alexander. Yeah, may we practice calculating the surface area and volume of right prisms and pyramids. By the way, today we're going to need our pencil, math notebook, calculator, Chromebook. You're right, I did not get that set up by the time that you guys were here, and that's what it's for, so I think you guys do deserve a couple points for that, as we discussed. Yay! Okay, so your Wasatch teachers, let's start with a warm-up. Down in room 110, she teaches drama. That is indeed Miss Dallimore. And then things with springs, alarm clock is what we're looking for. Alarm clock is what we're looking for. Very good. Okay, let's see here, guys. Underneath all this, got a pencil? Okay, today's topic is surface area and volume of pyramids and prisms. We had an extra day to feel really good about these, okay? Let's see here. Let me get a couple of accent cards. Actually, you know what? I should shuffle them for reals because today anything will work. Even the weird ones will work. So we can actually make it totally random today. So let's see what happens here. Shuffling those, picking the first three. There we go. See what happens. Okie dokie. Let's see here. Right. Nope. Give me that back. Okay. So let's say that this is a candle and it's in a box and you get it. You ordered it online and there it is. But the candle is not itself shaped like a rectangular prism. Yes, go ahead.
I can't believe this. I need to sue that company. They
Oh.
didn't tell me that flames weren't included.
It's true. It wasn't on fire when you purchased it. Yes. So you guys might be able to imagine the shape given what we've been talking about, right? Yes, as you can imagine, guys, that candle is a hexagonal pyramid. We're going to draw it from below to help you see it better, okay? So here we go. Let me go ahead and get that. So I'm going to help you draw this thing the best I can. So everyone draw a hexagon. So to draw a hexagon, what you do is you start by drawing like a trapezoid, just like a standard trapezoid, and then you draw its mirror image below it. So we're going to say that that's a regular hexagon. And that it's a right pyramid besides. I don't know how you guys feel about the see-through lines on these things. You know what I'm talking about? Personally, I hate these. These things give me the wailing fantods. Like, I hate looking at them. Like, I don't know, where are you guys? On the little dash lines for the see-through ones, big thumbs up, I like them. Big thumbs down, I do not care for them. Where are you guys? You know, I never do them, so I'm gonna leave them on this one. You know what? I'm actually, oh, we'll be okay. We'll be okay. So if you look at the dimensions of that box, guys, the dimensions of that box actually tells us a lot about this. For example, it tells us the height. That would be the distance from the base here, from the base to the top. Do you guys remember how tall this candle was? It was 9 inches. And we can also find out what the apothem is. Because do you remember, guys, the box was how far across? It was 5 inches. So what does that make the apothem? Not 5. I heard, yep, Kale got it. 2.5, right? Because the apothem is halfway across from the center to the outside. So this is 2.5 inches. Now, that's going to tell us everything we need to know in order to find the area of this triangle. You can actually use that to find the slant height that I have not given you for the surface area. So when I say teach, I want you to say, okay, this is your worst case scenario for in seventh grade stuff. Is something like a hexagonal pyramid or something with like a regular n-gonal pyramid hanging out on it. So see what you guys can do. I'm looking for the surface area and the volume of this thing. Round any side slant heights to the nearest thousandth, please. Give it a shot and teach.
Ah, boy.
Perfect, thank you. Woohoo. That be me. Oh, I need to give those to you, don't I? You're right, you're right. I forgot to give you something. I forgot to give you something. You're right, absolutely true, Ani. In fact, thank you, Ani. That is... It's true, but Ani is the one who told me, Mr. Peterson, I think you made a mistake. Like, that's important. Yeah, I forgot, guys, that you're going to need that. Now, again, I'm just going to make it up, but just so you know, like, there's a lot of crazy math that, like, if I actually had some time here to come up with this, I could come up with exactly what that was, but that's not something that you're going to see until secondary math 2. So I can't show you what it is. Right, but I'll just make one up. Let's just go ahead and say it's 3.2 inches. That ought to do her. Give it a shot and teach. They'll all be the same. So you can't use the original because the base is different. You can't use the original because the base is different. Mm-hmm. That's another lawsuit for another lawsuit. Give it another minute 35. How's that coming, guys? Thumbs up, all done. Index finger, need a little more time. Wave hand, need a lot more time. A lot of index fingers. Keep it going, guys. Keep it going. Oh.
You're a genius. You're a genius.
Okay. Can I get you guys back up here in 5, 4, 3, 2, 1? Let's see here, guys. Voices off, please. Let's see here. Ethan, do you want to help me out with a volume or that we don't have? What is it? Yeah, there's this slant height. I need to know the height of this, the slant height of that triangle so that I know what it's, so I can find its area. Root of, well, I'm just going to do it. Let's see. So what Ethan's saying is he wants to use the distance formula, or the just the Pythagorean theorem straight up, is 2.5 squared, that's this leg, plus 9 squared, which is this leg, which is, well, let's see, TI Smart View TM30X slash TI34 Multi-View. Oh! Oh! TM calculators, Texas Instruments, loading menus toolbar, validating software license, start. Dot, dot. There it is. Okay, so we're going to use the Pythagorean theorem, which is the square root of a leg squared. Yes, a leg pi. No, a leg squared plus a leg squared. And we get 9.341 approximately. So this slant height is 9.341. Did I remember that correctly, guys? 9.341. Did I erase it correctly? No, I did not. 9.341 inches. Cool. So, voices? Thank you, Ethan. I appreciate that. Let's go ahead and just get so. There we go. Let's see here. That's going to be Kale. Para los, no sé cómo se dice surface area, pero the surface area de este hexagon y este triángulos. ¿Qué quiero? ¿Qué quieres? Ayúdame con la base o con los triángulos.
Okay, now listen. Contrary from popular belief, despite how much I raid Spanish ships in pirate video games, I do not speak your language.
Sí, no tienes problemas, pero con mis manos. La área, ayúdame con la área de este hexagon o este triángulos. ¿Triángulos o hexagon?
Triangles.
Triángulos. ¿Qué es la área de este triángulos?
So, one triangle is 9.341 times 2.5.
Sí.
3.2.
Gracias. 3.2. 3.2. Y este número es 9.341 multiplicar 3.2. Está a 29 y 8912. Pero un triángulo, so necesitamos dividir aquí.
Multiply that times 6 to get all of the triangles.
Ajá. Bien, pero tienes un poquito problema. ¿Qué es el problema aquí? ¿Qué es el problema aquí? Sí, Ross. Sí, este es triángulo, necesitamos dividir a 2. So, dividir a 2 está 89.674. 89.6. No, una 674. Para este triángulo. Pero, ¿qué es la área de este hexagon? Maya, ¿qué es la área de...
Oh no.
¿Cómo se dice dentist en español? Oh, ¿qué? Ortodonta. So, a la ortodonta tienes ¿qué es la área de este hexagon? No, problema. Ok, tienes 6 triángulos. ¿Qué es la área de este triángulo? ¿Qué? Sí, de 2. Tienes 2 alrededor. Y dividir a 2 está 4. Sí, 4 multiplicar 6 está 24. ¿Y qué necesitamos con la área aquí, Maya? Sí, no, sumar un 100, 13.674. ¿Cuántos estudiantes quieres? Un 100, un 100, 13, a la 30.674. Excelente. Este es oigan,
Oh yeah. Oh.
Oh, yes,
No,
Shakespeare!
no, no.
Shakespeare! Another one.
People watching it.
hold on.
Don't waste it.
Isaac! I said the song of all your is Hey, that's all the time. This is what the hell? A guy outside the dishes. That's high. Thank you, Lord. Howdy, Ah,